Alrighty guys, what's going on? It's Professor Kirk here with part 3 of our chapter 1 series. Today we're going to talk about muscle fiber types and just the different ones that you'll see probably on your testing exams, and probably also what you'll study in your field if you decide to go into research or teaching and such. We're not really going to go too deep into them. Keep in mind that these videos are just broad overviews for you to understand the general ideas and concepts. So with that, let's get into the first part. So with the 3 types of muscle fibers, really only 2, but one of them has a subcategory, which is type 2. But we're going to start with type 1. With the type 1 muscle fibers, these are the type of muscle fibers that you'll see in people such as marathon runners. So people who are doing constant exertion are using them, are contracting their muscle fibers for long bouts of time. Now with these type 1 muscle fibers, we consider them slow twitch just because they move slower. But also what we see with these type 1 muscle fibers is that they generally have smaller neurons and can innervate usually less than 300 muscle fibers per neuron as such. They're also subject to this thing called aerobic respiration, which is basically stating that these muscle fibers rely heavily on the usage of oxygen. So that's basically what you'll need to know for the type 1 muscle fibers. Now moving down, we have the type 2A muscle fibers. Now these muscle fibers have usually much larger neurons. They'll generally innervate more than 300 muscle fibers, give or take. And we consider these to be anaerobic, at least the type 2A, well, both type 2A and type 2B. We consider them both to be anaerobic. And the reason we say anaerobic is because usually when you're doing these activities, you're not really relying as much on things such as oxidative phosphorylation. You do activate it to a degree, but nowhere near as much if you're using type 1 muscle fibers. So that's the big differentiating factor. It depends on how long the activity is, which will tell you which muscle fiber that you'll be using the most. So from type 2A muscle fibers, I call them medium twitch, essentially. So imagine you have a track runner and they're running a 1600 meter run. That's 4 laps around the track, which is a lot, but it's nowhere near as much as a marathon, what you would use for type 1 muscle fibers. But then progressing from the type 2A muscle fibers, we now have the type 2B or type 2X. People call them either or. I'm not sure how your textbook has it, but you can look at it and it can definitely tell you. It'll either say B or X. Now with these type 2B or these type 2X muscle fibers, I'm just going to call them X for this video. These muscle fibers have the largest neurons, and they definitely innervate more than 300 muscle fibers. And these are also considered anaerobic because you don't need to use as much oxygen when you're doing these activities, primarily because they're only used for high power intense situations. They're not used for long-term running or even middle distance running. So you're not doing a marathon or a 1600 meter run. You're doing something like a 40-yard dash or a 100-meter sprint. And these type 2X muscle fibers are used especially for high power events. And people say, all right, anaerobic, that means like lack of oxygen, right? Yes, you're still breathing. However, the systems of oxidative phosphorylation that we'll learn later, which require a lot of oxygen, essentially have not kicked in yet. That's why we consider these to be type 2X muscle fibers, because they don't really use those processes as much. In the last parts of our video, we're going to talk about contractions, a different type of muscle contraction. The first one we're going to talk about is dynamic contraction. So dynamic literally just means movement across a joint. So you see how I have my hand here and this is my wrist. If I do this, my wrist is in flexion, right? And there's a joint right here. I believe it's called radial ulnar joint. I believe this is the one that's called. I forget. But anyway, so we have a joint here. And if I'm flexing my muscle, I'm moving it across the joint. The joint is right here. It's going back and forth, back and forth. That is a dynamic movement. However, if I want to conduct something called an isometric or static movement, what I would do in order to engage those muscles, I would just flex my hand. And you see how that joint hasn't moved? Nothing's moving around that joint, but the muscles are still being activated. That is what we consider an isometric or a static movement. Now, moving on from here, there are 2 things that are kind of synonymous with the 2, but they have a slightly different definition. So next we have a concentric contraction, which is also known as like flexion. And the definition of concentric actions or flexions per se are just the decrease in angle between 2 different objects essentially. So let's say if I have my arm like this, right? And the angle right now is 180 degrees, my hand to my wrist and such, right? But if I do this, I decrease the angle between both of them. That is a concentric motion, also known as flexion. The next one we have is called eccentric, extension, right? So if I have my hand here, if I have my wrist here in flexion, and then I put my hand out like this, it is now extended fully. And the definition of eccentric motion is literally increasing the angle between two objects. So here I have an flexion, but if I want to extend it, that angle is going to become increased. And the last two things that we're going to talk about right now are the speed versus force, I guess, theory or hypothesis. Essentially, this just states that the faster you do something, the less force that you can apply, or the more force that you generate, the slower that you'll have to go. So imagine like a football player, right? Like he's trying to generate, he's trying to bench press 250 pounds, right? He can't do that fast. So as a result, his speed will go down, but his force will increase. The same is true if I had like a track runner. If a track runner wanted to, I guess, go as fast as possible, they couldn't have a bunch of weight on them. That's why you see those track stars. They're very lean, they're very strong, because they want to be able to move essentially as fast as possible. They still have a lot of force, but that force is more talking about the weight that goes along with it. So the next thing that we have is to talk about is the length versus tension. This is more so talking about the optimal level of sarcomeres. So essentially what this hypothesis states is that sarcomeres have to operate in an ideal range. If it's too small or if it's too large outside of that range, no force can be generated. The muscles can act or muscles can contract in the way that they want to. And essentially what you'll get into later is this thing that we talk about. It's called an all or nothing principle. It's basically saying that all the muscle fibers have to be contracted and stimulated in a similar fashion and in a appropriate fashion. And if not, you won't be able to move that muscle. And that's what this length versus tension hypothesis is kind of talking about. You have this slideshow I think you have this graph at the bottom of your slideshow that you'll be able to view. But yeah, that's all. That's what we're going to cover for today, guys. If you have any questions, feel free to let me know. You can reach out to me, email me. But that concludes part 1 for this class.